unit 3 get?
Say that again.
Sir, will unit 3, this like production theory, get completed today itself?
Yes.
Okay, sir. And sir, what is the next unit?
Number 4, monopoly.
Okay, sir.
Yeah. Okay, let me share the screen. Okay, so we discussed properties of the cost function and all, but what the firm is ultimately doing is profit maximization. Okay, so what are the implications of profit maximization for the firm's demand and supply functions? Demand for inputs, supply of output. Can we say anything on that? So to see that, what I will do is do a gear shift. I will now try to tackle the profit maximization problem directly. Yes. Instead of the two-step process or two-step method of solution, construct the cost function, then do profit maximization. Let's try to do profit maximization directly. Maybe I'm missing a slide here. Okay, so this is the slide. So the firm has a profit function. Okay, so this is the direct way of trying to maximize profits. The choice is the input vector. Once you choose the input vector, the output is determined by the production function. So instead of writing y, we'll replace it by fx, the production function. So now the problem is an unconstrained maximization problem where the choice is the various inputs. Okay, so this is, and once we solve that problem, that gives us the profit function. So profit is a function of all the parameters of that the firm faces, namely the price of output and the various input prices. So if we tackle it this way, then our first order condition, assuming an interior solution, right, not worrying about corner solutions at this point. If I differentiate with respect to any of the inputs, let's say the ith input, okay, xi, and set the derivative equal to 0, we get this. From the first term, we get p, that's a parameter, times the marginal product of input I, which is del f del xi. That should equal wi, the price of the ith input. Okay, so this can be stated as marginal revenue product equal to price. This is called marginal revenue product. Okay, this is the marginal product of the ith input in terms of physical quantities of output. Okay, how much an extra worker, how many cars will be produced in a year if we add a worker to the workforce. That's that quantity. Multiply that by the price of each car. That is how much monetary value that extra worker is generating. So that's the marginal revenue product of that extra worker. That has to equal the price of that extra worker, which is the wage that has to be paid to that worker. So this is the usual marginal condition, right? Again, this crops up over and over in this sort of marginal analysis. What is the second order condition? It's a condition on the Hessian matrix. It has to be essentially locally concave, so its Hessian matrix should have the relevant property. Okay, moving on. Let's define these two functions. These are the choice functions of this profit maximization problem set up in a direct manner. So whatever is the optimum value of x, that gives us the input demand functions. And these are unconditional input demand functions. When we were looking at it through the lens of the cost minimization exercise, which is only a part of the profit maximization exercise, we got conditional input demand functions and conditional supply functions. Well, conditional input demand functions, because it was conditional on some arbitrary output level. Here, the functions are falling out of the full-fledged profit maximization exercise. So these are the true unconditional input demand functions, and this is the true unconditional supply function of the firm. Give a vector of input output prices to the firm. This is how much this function tells us how much it will supply to maximize its profits, and this functional, this sort of vector, tells us how much of each input it will demand. Now, does the law of demand and the law of supply apply to these functions? That's one of the questions we are interested in. So now that question can be answered very simply by exploring properties of our profit function, of this value function of the profit maximization exercise. So let's discuss these properties. Some of them are fairly straightforward. Properties of the profit function as defined in the previous slide. Okay, so the profit function has to be increasing in the price of output. That's very easy to see. Okay, there's a very straightforward argument which will establish this. If the price of the output goes up, the firm may not even change its decisions. Even if it continues to buy the same amount of inputs from the market and produce and sell the same amount of output as before this price rise, it'll make higher profits simply because every unit it's selling fetches a better price now. On top of that, of course, the firm will adjust its input vector and its output level. But even without that adjustment, its profit has to increase. So the profit function, therefore, has to be increasing in output price. And exactly the same logic says that, it has to be decreasing in each input price. For example, if one input becomes cheaper, again, even without changing or adjusting its decisions, the firm can earn higher profits. So there's a negative relationship between profits and input prices. A third property is that it's homogeneous of degree 1 in all the prices, input and output. So if all the input prices double and the output price also doubles for some reason, then homogeneous of degree 1 means that the firm's profit will also double. Okay. Why is that? Well, you can go back to your first order condition. Okay. So this is true for input I. This is also true for input J. Okay. So if I divide, I get the ratio of marginal products of input I and input J should equal their price ratios. So if all the prices double, then the price ratio of the two inputs doesn't change, which means that the amount of input usage of each kind does not change. Okay, so when this happens, all the prices double. Okay, the firm's decision how much input to buy, how much output to sell, that remains unaffected. Okay, and that means that its profit also has to double because both components of the profit, the revenue part as well as the cost part, has doubled. So the difference between them has doubled. Right, the same X vector continues to be the optimal choice of the firm. So another way to put it is to say that if there's uniform inflation in the economy, not only does each individual or household have twice the nominal income, each firm also has twice the nominal profit. Okay, so last two properties, and these are the important ones. The profit function is convex in the price vector. Okay. And Hotelling's lemma is similar to Roy's identity and Shepard's lemma that we discussed earlier. Hoteling's lemma gives us a connection between the value function of the profit maximization problem and its choice functions. Okay. So for some reason, if we know the profit function but don't know the input demand and output supply functions, we can derive those latter things from the profit function through appropriate derivatives. So derivative of the profit function with respect to the output price gives us the output supply function. Derivative of the profit function with respect to the input price gives us the input demand function with a minus sign. Okay. Which mathematical result can we use to prove these two? Oh, answer is already there. No point asking it. Envelope theorem. Yes. So you've seen this before, so let me not talk about it. Let's think of this property, that the profit function is convex. Okay. The proof is exactly like the way we proved concavity of the expenditure function. It's using the inequalities. Yes. It's exactly the same line. So again, let me not repeat that either. Let's take it as given that profit function is convex. You should go through the steps over here to satisfy yourself that the claim is correct. Tulika, do you have a question?
Yes, so can you please move to the previous slide?
Yeah.
So in the point of homogeneous of degree 1, so when we are saying the prices of all the input and the price of all the output doubles, then don't you think the profit remains unchanged?
No. What what is critical here is that when everything doubles, the input vector, which is optimal for the firm, remains the same. Okay, that I explained to you. So if you're satisfied with that explanation, that when P as well as all the W's double, the X remains unchanged, okay, then you just look at profits. Essentially, everything in the expression of profits has been multiplied by 2. So that goes outside. So now profit is twice as much as it was.
Oh, yes, sir, got it.
Aishwarya.
Sir, I had two questions. So the first one being that the envelope theorem is actually a theorem that has to do with constrained optimization. So how are we using envelope theorem to derive implications of an unconstrained optimization?
Okay, let me answer that. Then you can
Yes.
ask your next question. The answer to that is it applies to constrained optimization. Now, unconstrained optimization is a special case of constrained optimization with no constraints whatsoever. Yes. So constrained optimization is more general case. So it applies also to unconstrained optimization problems. When I was explaining the constraint, I gave you some sort of a proof of the envelope theorem, if you recall. I gave the proof for an unconstrained optimization exercise. And then I just said that, it generalizes when you have constraints in the following manner. So yeah, it still applies. The Lagrangian, when you have an unconstrained problem, right? Envelope theorem says that the slope of the value function equal to the slope of the Lagrangian. If you have an unconstrained problem, then the Lagrangian is essentially the objective function, the function that you maximize.
Right, sir. Got it. Sir, the second question being, sir, could you please go to the previous slide?
Yes.
Sir, how can we say that the profit function is convex? Because we know that we're essentially doing this exercise for decreasing returns to scale. So we know that our production function is concave, and we're just multiplying it by a constant a price vector. So it's essentially remaining concave. And then we're subtracting an essentially a linear equation. So how can the profit function be convex?
Well, the mechanical answer to that is it's the proof. The proof is there on this slide, okay? But I think the reason it's you're kind of scratching your head about that is that, you know, when I was discussing, okay, decreasing returns to scale means convex cost functions. That was only the cost function. For the profit function, there's no such link, because for the profit function, when you're taking two price vectors and averaging them, right, you're averaging not only the input prices, but also the output prices. Yes. So when, you know, when you're doubling input prices, you're also doubling output prices, for example. Whereas when you are studying the cost function, all the properties is with respect to the output price is irrelevant over there, right? All that matters are the various input prices.
So, but the fact that the production function is concave doesn't change, right?
It doesn't
So
change, but the production
does.
function. So there are two completely separate questions. What are the implications of a concave production function or decreasing returns to scale on A, the cost function, B, the profit function? Here we are talking of the implication on the profit function. So yes, concave production functions mean convex cost functions, or convex production functions mean concave cost functions, but no such linkage exists with the profit function. The profit function is always convex.
Okay,
Because
sir.
it's a different object. It's not the same as the cost function.
Sir, I was of the opinion that an addition of two concave functions is essentially concave, but I realized that this is not an addition.
Yeah.
So yes, I got it, sir. Thank you.
Yeah. Okay. So now here's the final step. Aishwarya, you just asked the question, right?
So I'll lower my hand. I'm just.
Okay, now let's take, what are the implications of the profit function being convex? If you remember, the calculus definition of a multivariate function being convex or concave, we discussed it earlier. It can be characterized by properties of the Hessian matrix. So I'll go back and borrow what we discussed earlier. Since the profit function is convex, its Hessian matrix has to be symmetric, positive, semi-definite, which means that its principal minors all have to be non-negative, weakly positive. Yes. So the first principal minor here will be positive, then the 2 by 2 matrix, its determinant will be positive, so the 3 by 3 and so on. As you remember, the Hessian matrix consists of the second derivatives of the function in question. If the function is convex, its matrix of second derivatives is the Hessian matrix, and that has this property. Okay, principal minors are all weakly positive. And here we can apply. So this matrix has this property, right? But this matrix can also be written in this manner. Why? Thanks to Hotelling's lemma. Yes, thanks to this. So for example, if you look at the first row, right, what are we doing? We are taking the profit function. In each case, we are differentiating it with respect to price. That's common to all of them. And then we are differentiating it with respect to each of the input prices and output price. Okay, so every del pi del p is essentially y, the output supply function. So this vector of second derivatives of the profit function is the same as this vector of the first derivative of the output supply function. Similarly, this second row, the common derivative, if you notice, is del 1. Everything has del 1 and then another del. So del pi del w1, sorry, del w1 I meant. So del pi del w1, the derivative of the profit function with respect to the first input price, is the first input demand. So all these derivatives can be written as some derivative of the first input demand function, and so on. Okay. So dwell another minute on this when you're studying this, and you'll see that these two matrices are equivalent. So if the principal minors of this matrix are all positive, then so is the case with this matrix. And one implication, as you saw when we were discussing the Slutsky equation and the Slutsky substitution matrix, that one implication of the principal minors being of a certain sign, it also implies certain signs for the diagonals. So here everything is positive. So the first element, right, the first principal minor is just del y del p itself. So that has to be positive, right, or at least non-negative. And it is very easy to deduce that all the other diagonals also have to be positive. And now if you look closely at the diagonals, what do we have? The first thing is the slope of the supply function. What happens to supply of the firm when the price of its output rises? Other things remain the same. So we have inferred that is positive. So supply curves are positively sloped. No ifs and buts, no qualifications, no given good business. Supply curves are positively sloped. And each of the input demand curves have to be negatively sloped. That's the other implication that we derive, right? So when it comes to the firm, unlike the consumer or the household, we can give unambiguous answers about their demand and supply functions. All their demand functions for all the various inputs are downward sloping, no given inputs, and its supply curve will always be upward sloping. Yes. Okay, now let me ask a question. In consumer theory, at least for Marshallian demand functions, which is what we observe, we couldn't say unambiguously and confidently that demand curves will be downward sloping. The possibility of given goods was always lurking in the background. When it comes to the theory of the firm, all their demand curves are downward sloping. No given inputs. So why do we see this difference?
So maybe due to the inexistence of income effect.
So there is some critical difference between the consumer's problem and the firm's problem, and that has to do with the income, as you're hinting. So what is the difference?
So the firm does not have any upper limit as to how much it can produce. The consumer does have an upper limit as to how much it can consume.
That's exactly right. Right. The consumer is on a fixed budget. It cannot scale up its purchases. He has to live within his means. The firm has no such constraint, at least in this theory, right? If there's a profit opportunity which requires buying more inputs and scaling up its production, this theory assumes that the firm will be able to do that scaling up business. Often, the timing matters. Often the firm has to buy those inputs first, so it has to spend a lot of money upfront, and then after selling, it gets a lot of revenues and profits later on. But it has to be able to finance the scaling up. So this theory implicitly assumes that this sort of upfront financing is always possible, and I'm returning to this point in a moment. But that is the critical difference between the firm and the consumer, right? The firm has no budget constraint. It can scale up whenever it wants. But the consumer had a budget constraint. And that is what creates the difference between the input demand functions of firms and the commodity demand functions for consumers. Yes. And income effect, exactly. Income effect arises because the consumer is on a fixed budget. Okay, now let me ask the question, let's examine this assumption that if the firm finds a profit opportunity, it can spend a lot more money upfront and sell that output and earn a lot of profits maybe a month later, we are assuming that the firm somehow has the ability to spend all that money upfront. Yes, I think it discussed it earlier in one lecture, but let's touch on that point again. Now that's a non-trivial assumption. Yes, in the real world, so the firm can raise those funds, by borrowing from the banks, by floating new shares, for example, IPOs, okay, through equity or debt, venture capital funding, whatever. We are assuming one way or another, through some financing method, the firm will be able to raise the capital, the funds that are needed. Is that always true in the real world? Is this an overly simplistic assumption?
So, I mean, to some level, it is true for the short-term expenditures. The firm can always raise credit through banks, realistically speaking. But yes, of course, if we take it mathematically that it can raise infinitely large amount of funds, then of course it's not possible.
Even for reasonable amounts of funding, there's often credit crunches. Okay, if you're thinking of massive, giant corporations and well-known companies, Apple, Google, companies like that, they often have very good credit lines, right? So Apple comes up with an innovation, it wants to expand. There'll be a lot of takers. Apple can float new shares. Apple can borrow. In fact, for the big tech companies, they have huge cash reserves, so they can even do internal financing. Right? Their past profits they have accumulated, and they so plow it into R&D, into expanding into new markets. I think so. The top few, I just read somewhere recently, they have something like $500 billion of cash reserves. Yeah. Which they haven't paid out as dividends. Okay, so the big, powerful firms may, this assumption may not be too bad for them. But there have been studies on small and, SMSEs, small enterprises, informal, semi-formal kind of enterprises in developing countries, which shows that there are very serious credit constraints, right? How do they do that? There are studies. There's one study by Asantha Dimel and others on Sri Lanka. There's another study by Banerjee and Tuflo on India. And there are many other studies in poorer countries, Africa and so on. What they do in these studies is they do randomized control trials, RCTs, okay? So they look at a bunch of small firms. They randomly select half of them and give them some free money. Okay. They see how much their profits went up after a year. So that gives you the returns to capital in these firms. Okay. What they find is, and since the placement is randomized, there's no selection effect. So it's a good estimate of what an average firm of this kind, how much extra profit they can generate if they were given more funds. Okay. And the returns to such investment, the annual returns, are very, very high, right? In Sri Lanka, I think the average they found was something around 80%, right? In some countries, it's more than 100%, which would mean that, if you invest some money in this fund, the extra profits in a year will within a year, the money will be recovered. So these are astronomically high rates of return. So what should have happened if the credit market functioned like a classical, market is that most of the lenders, take the institutional lenders like banks, the highest interest rate they get is, credit card interest rates like 25% max. So there is this huge unutilized opportunity. These lenders, these banks could have lent to these entities, and they could have charged an interest rate between, let's say, 25% and the 80% that these guys found for Sri Lanka. Let's say they charge 50% interest rate. So that would create profits both for the borrower and for the lender by healthy margins, right? The borrower would still keep, after paying off the debt, the difference between 80% and 50%, that 30% gap, that'll be pocketed by the firm. The difference between 50% and 25%, right? 25% is the highest the bank was getting. That difference is pocketed by the bank. So there seems to be this opportunity which the market somehow has not been able, the credit market has not been able to exploit. So the bottom line is that even though some firms are extremely profitable at the margin, somehow the financial markets don't get the money to them, and they're not able to take advantage of these profit opportunities. So in the real world, things are complicated. Now, why this happens, that's another Pandora's box, which I'm not going to open now. There are lots of theories having to do with asymmetric information, why credit markets may freeze like this. But the bottom line is that this assumption is not at all innocuous, this assumption of classical theory. And that's something you have to keep in mind. Nilava.
Sir, when the firm is upscaling its production, do we assume that the technology remains constant?
The technology is captured, every aspect of the technology is captured by the production function. So if bigger scale production has some advantage, then the production function will be increasing returns to scale, and that will capture that. So we don't have to think beyond the production function about what happens at larger scales. The answer to that is already captured in the production function.
Okay, sir.
Shishir.
So if we may think of introducing this budget constraint within firms as well, how would that optimization problem look like?
Oh, then, for example, the input demand functions will start having that ambiguity that they may not be downward sloping. Right? There's a possibility of given input demand, given inputs, for example. Yes. So then we can just borrow from our consumer theory to say whatever we can say. Okay, short trick.
So, sir, in that example of treatment group and control group,
yeah.
So what is the time frame? I just want to suppose initially the treatment group do well, but don't you think, sir, we need to check the time frame also, that for how much time they are doing well and coming out of the cycle?
This is true for almost all interventions, that there may be a conflict between short-term effects and long-term effects. But it's difficult to see why the long-term effects in this case would be opposite. Okay, so if a firm gets some cash infusion and earns a lot of profit, and even after paying off the debt, they retain a lot of profits, it's difficult to see in the long run why their output will shrink or their profit will shrink. They've just got a dose of capital infusion from which they themselves have retained a big part. So even if you allow 5 more years to pass, it's difficult to see why anything will reverse as a result. Okay, but what people sometimes worry about is, for example, you run, let's say, awareness campaigns, and it changes people's behavior. You say, okay, there's a lot of benefits from wearing face masks. You run that campaign in the local market, and you look at whether it changes behavior, and you see people are wearing more face masks. Sometimes the behavior dissipates. You go back after a month and see whether the behavior is better. You find that no, people have forgotten by now. So sometimes there's dissipation of that, and you can sort of ask the same questions in these studies, that in the long run, is there an impact on the firm's output and profitability? That's a fair question. I think, I don't know how long a follow-up these studies have. I have to go back and look at the details. Yeah.
Actually, sir, I was going through a paper of same Abhijit Banerjee and Esther Duplo. So it was about applying that in the state of West Bengal on poor households. So there he mentioned that we don't check that how in long run they will behave, though it was on poor farmers, but in long run they will behave.
Yeah, so some of the studies they has tried to address this question. For example, microcredit in Hyderabad, which the two of them, they've been doing a study and they've tried to make it long term. Yes, and trying to distinguish short term impact versus long term impact. Yeah, that's always an issue.
And sir, nudge that today I am applying will not hold, like as you were saying. The nudge of today, the nudge I am applying today may not hold after 10 years.
That's right. But nevertheless, all of that is true. So for practically all interventions, this is a very general question, which goes from growth theory to all kinds of government programs and social programs, everything that is the long run impact. How sticky are things? Have some intervention, some change. In the short run, it has an impact. How sticky is that as more time passes? So that's a general, yeah, I mean, I agree with you. That's a pervasive question for almost everything, right? And in different contexts, the answers differ. In some situations, things are very sticky, they persist in the long run. In some situations, they don't. And we need to understand that temporal aspect theoretically as well as empirically, and there's huge literatures on both sides. But nevertheless, with these kinds of rates of return, right? If the rate of return is more than 100%, it doesn't matter, at least for the lender, whether things are sticky in the long run. You'll recover the money in 1 year. So that opportunity is worth seizing. Yeah. Aishwarya.
So the classical model that we have built is essentially a long-term model, right? Because we're assuming that all the inputs can change.
Well, it's literally speaking, it's a short-term model. It's one round of production. But depending on what you want to do, you can perhaps extend it to the long run.
So, sir, then why are we considering returns to scale rather than returns to a factor if it is a short-term model? Because
all those things
in the short term, all inputs can't change.
See, that's, in your traditional textbooks, there's a huge amount of time spent on short run versus long run. In my mind, it's just a waste of time. Yeah. Essentially, you can, all this analysis that we did, go back to the production function, right? FX. Fix your time frame. 1 month, 1 year, whatever it is. Just ask the question, which are the inputs which can be changed within this time frame? Okay. And use that production function. So this FX can be the production function relevant for a month, relevant for a year, relevant for the next 10 years, what have you. This practically the same analysis applies. There's little bits to be said here and there, but this huge fuss which undergraduate textbooks make about it, as if the whole logic is different from short run versus long run, is just a waste of time. Yeah. So take your time frame, take all the inputs which you can change in the time frame, and just do this analysis. The only caveat is that, for the other inputs which you can't change, you may have to be paying fixed costs, and whether you should stay in business or shut down, that fixed cost will play a role over there. But setting that aside, none of these principles like price equals marginal cost for cost minimization, marginal revenue product equal to price of input, every principle is the same. If you're talking about next week, maybe you take your production function only as a function of labor, if you can hire just some more temp workers. If you're doing the analysis for the next 6 months, where you could buy some more computers, then your production function includes people as well as computers, and you do the corresponding analysis over there.
All right, sir. Understood. Thank you.
You know, in evolution, there's this concept of junk DNA. You know, a lot of the genes that we have, let's say as humans or any other species, these are sort of holdovers from the past. They don't serve much useful function today. It's just that they're there. You know, they serve some useful function in the past. So traditional econ textbooks have a lot of junk DNA, in my opinion. And this whole page after page about short versus long run is of that nature, in my view. Anyway, so I'll stop here. There's only one more thing to discuss. This entire analysis, well, not this entire analysis. If we now extend this analysis to the market, if we assume there's a fixed number of firms in the market, each of them has a supply curve as determined by this profit maximization exercise. We have to add up those supply curves to get the market supply curves. Then we bring in the demand curve, and the intersection gives us market equilibrium. So we can do the analysis assuming a fixed number of firms when we are analyzing the market. And that'll be fine, okay? But often in markets, entry and exit are possible. New firms can come in if there's a lot of profit opportunity in the market. And if the firms are making losses, then some of the existing firms may quit. Yes. So there's another layer of analysis that we can do where we allow endogenous entry and exit of firms. Okay. So that part I'll talk about in a subsequent lecture. That what happens to market equilibrium where entry of or exit of firms is possible. And essentially entry will stop at the point where after profit maximization, firms are making zero profits. So when you endogenize the number of firms in the market, the zero profit condition becomes an additional condition that describes the outcome. But at this point, let me not talk about it. If for some reason the number of firms in the market is fixed, everything we have discussed straightforwardly gives us the market equilibrium. And there are problem set questions where you have to solve the firm's cost minimization, construct its supply function, and then take it to the market level and find market prices, output, etc. So you should be solving those questions at this point.
So it is essentially just multiplying the supply function by a scalar, right? So it boils down to just that, isn't it?
Yes, except that what you're multiplying by will be endogenous. It won't be some constant number. It'll be that scalar which creates zero profits for the last entrant in the market.